Our learning target today is I can identify and interpret the constant of proportionality. So what we're going to do is I'm just going to do like a multifaceted problem that looks at tables, graphs, and equations to derive the constant of proportionality. And then we'll talk about those and compare those. And then I do have one little thing that you're going to need to know for your homework tonight, and that's what you do when your equation is not in the correct form and you need to find the constant of proportionality. Okay? So let's get started. Okay, we're going to talk about Daisy and a couple of her friends, but first of all, Daisy attends college in another state. She drives home for summer break. She keeps track of her drive times. Okay. So the way that she keeps track of her drive times is she does it in a table. So that's what we're going to do. We're going to look at Daisy's drive times in a table. So I'm going to set up a little table for Daisy. Okay, and if you're wondering what I'm doing here, I'm making a table that is 8 by 6. So if you want to block off your squares, I did 8 across, 6 down. Okay, and we're going to compare the time in hours to the distance in miles. Okay. So let's take a look at her data. In 3 hours, Daisy drives 180 miles. In 2 hours, Daisy drives 120. In 1.5 miles, Daisy drives 1.5 hours, Daisy drives 90 miles. And then 2.5 hours, Daisy drives 150 miles. Okay. I'll give you a second to fill that in. Okay, does anybody remember how to find out if this is proportional or not? Even if you kind of remember. Ayan.
Divide 180 by 3 and divide 120 by 2 and see if the rates are the same.
Yeah, so we'll do that for each thing inside the table. And remember that I'm also just going to throw this in here too, that this is always your X and this is always your Y when you're looking at a table. And so what Ayan is saying is take your Y column, divide it by your X column, and then we're going to do that for all of them and make sure that they're the same. Because if they're the same, then this is considered proportional. So 180 divided by 3 is 60. 120 divided by 2 is 60. 90 divided by 1.5 is also 60. And 150 divided by 2.5 is 60. So once we go through and we divide all those, we say, yeah, that's proportional, because the ratios were all the same, just like Ion said. And then now what we're going to do is we're going to find the constant of proportionality. Well, we actually already found it, because if you remember back to when we did this, to find the constant of proportionality, you divide your y by your x. I'm going to put a nice little box around this so that we remember that important piece of information. Okay, so now for this, we've already really done this, because our y is 180. We divided it by 3 and we got 60. So that means that Daisy's constant of proportionality is 60. All right, now we're going to talk about one of Daisy's friends, okay, Tommy. And we're going to talk about Tommy's drive. Now, Tommy does not like tables. Tommy prefers graphs. So Tommy has represented his drive with a graph. So we're going to set up our x and y axis so that we can take a look at Tommy's drive. 10 by 10 should be plenty here. This is my y-axis, this is my x-axis. And let me move it up so you can see. Okay, so we're going to go ahead and remember our x is time, so I'm going to write time down here. So time in hours. And then we're going to put our distance on the side here. So this is distance in miles. Okay. And now we're going to put a scale on this. So I'm going to do, on the bottom, I'm going to do hours every 2 squares. This will be 1, 2, 3, 4, 5. And then I'm going to go by 20s for my miles. So this will be 20, 40, 60, 80, 100, 120, 140, 160, and 180. Okay. And then I'm going to go ahead and put some points on this graph so that we can talk about it. All right, so let's take a look at this here. I'm going to zoom in a little bit so you can see that graph a little better. I'll give you a minute too to get it filled in. Does anybody remember how to find the constant of proportionality given a graph? Even if you're like kind of sure, don't quite remember, I still would love to hear it. Go ahead, Alan. Yeah, well then, yeah, definitely. You can use this point right here. What is the other name for that point right there on the graph? Does anybody remember? You think you know it, Ishan?
No. Something with
Unit rate.
unit rate.
Unit rate. You were right on that track, Maddie. Okay, so yeah, you can use the unit rate, definitely. Okay, and the unit rate, constant of proportionality, same thing. So what would that be here? What would that be at this point? Hang on.
50.
Yes. Yeah. Okay. But really, if it's hard to see the unit rate, all you need to do to find the constant of proportionality is pick one of the points where it crosses exactly at the crosshairs, like this point. This point is 2 and 100. And we can use our equation from above. We just divide the y by the x. So in this case, our y is 100, our x is 2. If we divide that, what's our constant of proportionality? Yeah, I heard it. 50. Okay, so constant of proportionality here for Tommy's drive is 50. Okay, so now we've looked at the constant of proportionality in a table and in a graph. And now we're going to look at it in a different form. We have another friend who is also driving home for summer. Her name is Alicia. Now, Alicia is going to represent her drive with an equation. So we have y is equal to 57x. Okay, and if you remember back to when we did proportionality at the beginning of the year, if you have anything in this form, the constant of proportionality is already right there for you. Okay, so in this case, whatever is being multiplied by your x, your k here, is going to be your constant of proportionality. I feel like this is the easiest form. It's super easy to see what the constant of proportionality is. So what is it, my friends? 57. Okay, so for Alicia, k is equal to 57. Okay, now I have some questions for you. I'm going to zoom out a little bit so we can see all three friends. Okay, you have Daisy, Tommy, and Alicia. Who drives the fastest? Lily. Daisy, and how do you know?
Because she drives 60 miles and everyone else drives less than 60 miles.
Who's going to say that? Yeah, awesome. Okay, who's the next fastest then? Gavin. Alicia. Okay, and then who's the slowest? Ishan. Tommy. Great. Okay, so the constant of proportionality is super useful when we're comparing. Okay, so you can find the constant of proportionality given a table, graph, or an equation, and then you can use that to decide, hey, so-and-so's the fastest, so-and-so's the slowest. And we'll look at problems, too, that involve money. Who makes the most money? Who makes the least amount of money? All that kind of stuff. Okay? So what we're going to do now is I'm going to show you one little trick, one little thing that I did not show you when we did proportionality earlier on in the year that you're going to need to know. So I'm out of space. I'm going to flip my page over. All right. Okay, you are going to be given linear equations that look like this, and they're going to ask you what the constant of proportionality is. Okay, but it's kind of hard to see when it's in this form. So what we're going to do is we're going to take this equation and we're going to try to get it into this form. Y is equal to kx. So we can actually see that constant of proportionality. Okay, so if you look at this equation, it needs to be solved for y. But right now, y is being multiplied by 12. But you have all these great skills from the last couple units we did, and you can use inverse operations to divide by 12 here to get y all by itself. Okay? Now what we have is 3 over 12 is 1/4. And then you have x. 12 divided by 12 is 1, so you have y all by itself. Now what's your constant of proportionality? 1/4. Okay? So k is equal to, sorry, not 1/2. And I'm out of whiteout. I need to get some more at the store here. So 1/4, okay? So the goal here is to get, if you're given an equation that is not in the correct form, is to just isolate your y using inverse operations until you get it in that form, and then you can see your constant of proportionality, okay? So let me give you a couple to practice. Okay, try to find the constant of proportionality from this one. And that one. It looks like most people are finished up. So let's take a look at these. Okay, on this problem, we could do one of two things. We could divide by 1/2, but that gets messy. But what other skill did we learn that we could use? Pernish?
We could multiply the reciprocal.
Yes. So I'm going to do that. I'm going to multiply by 2 here. And then these will cancel because 2 divided by 2 times 1/2 is 1. And then we're left with y is equal to 4x, which means k is 4. Okay, next one. We want to get y all by itself. We're dividing by 10. The opposite of dividing by 10 is multiplying by 10. So I'm going to do that here and over here. 10 divided by 10 is just 1, so you're left with y. And then 10 times 2 is 20. 20 divided by 5 is 4. So we have another one where our constant of proportionality is 4. How you guys doing with this? Good? You guys are silent today. All right. I'm going to give you the rest of the class to work on that practice. You have a good 5-6 minutes before you have to leave. So take out some. You can do your practice on regular paper. You do not need to do it on graph paper. We'll save that graph paper for another time. And here's your table of contents too. You too.